Well, it's a time of week again. Sunday, time for Stu's Place. This week, we're going to have Paul Têtu as a guest, and I'll be introducing his version of harmonic, universal harmonics there, and it's kind of like a combination of everything that we've been doing here, all tied in one neat package. Anyway, before that though, I'd like to remind everybody we have a conference coming up. Uh, this year it'll be in Albuquerque, 7th to 11th at the Crown Plaza Hotel. I still have a 35% discount if you sign up before uh, January 31st at this point. So I encourage everyone to do that. If you sign up 2 people, you can get an additional 5% off. The hotel rooms are anticipated to be at $84, start at $84, which is just a very slight increase. Last year they were 82. So it's going to be a very good rates. If you start planning now, it should be very affordable. Um, and like I say, with a 35%, bring a friend, make it 40. Then that's most of the cost right there between that and the hotel. You know, this is probably the most affordable conference you're going to go to. I mean, the breakfast is provided with the room. So you don't have to worry about your breakfast. And then also in the evening, every evening we have a social, and we always have something good to eat. Like we have taco bars, pasta bars, chicken. All sorts of good stuff to eat every night. So the only time you're on the hook for anything would probably be at lunch. And I'm working on getting some good rates for our lunch program there too. So I encourage everyone to come up. We'll be starting to upload names here in the near future. I encourage everyone to come. And for those people who like to do a presentation, I'm still accepting a call for papers. I'm still sorting through things. So if you have something that you have, especially hardware, uh, give me a call, 520-252-0374. Um, I'm usually available 24/7. You know, um, it's never too late. And like last year, we added on we added on 9 hours of presentation. You know, so I encourage everyone, if you have hardware or know someone, especially our young guys, we want to get these younger guys involved in this. Come to the conference, show your device, talk to people, teach people, you know. And if you're an older guy, hey, it's time to, start passing on the torch and sharing the information and mentoring the young folks, you know. So I encourage everyone to come to the conference, August 7th to 11th. Mark it on your calendar. I'll be there, and I expect you to be too. You all have a great evening here, and if you haven't already, sign up for the Tesla Tech YouTube channel. Um, what I've done is I only have one level of membership now, and it's $9.99, and that will get you access to all of the presentation we have up there, which is approaching 1,200 plus. And I'm putting more each week. In fact, I'll be putting some more up tomorrow for members only. And every week I'll be putting maybe about 2 or 3 free ones up there. But I'm focusing at members only for a couple of reasons. Number one, the censors on YouTube aren't so bothered or aren't as threatened by members only for some reason. And they only seem to be really upset at people when they do the public stuff. That's when they really crack down on you. And I want to encourage everyone, if you like our presentation tonight, okay, to take and smash that thumbs up on the below the screen there, and let YouTube know that. You're just very simple. Like I say, just hit the thumbs up, That's all you need to do. It helps our ratings, you know. And if you're not a subscriber, subscribe. Subscriptions are free. But if you really want to get the lowdown on everything, join us. You know, it's $9.99 a month. You know, just click the join button and take it from there. Tonight's guest is Paul Têtu. Welcome aboard, Paul. And you're going to be seeing a lot more from Paul in the future as he expands on what he's going to be talking about tonight. And so, do you want to tell us a little bit about yourself, Paul?
Sure. Thank you very much, by the way. I appreciate the opportunity. I live in Denver at the moment, but I'll be near Steve and attending the conference myself. I'm also a Tesla Tech member, or if I haven't done that yet, remind me after and I'll do that. I really would rather probably just get into it, I suppose. Welcome, everyone, guys, gals, non-binary pals. Let's see here. So, yeah, again, I'm thrilled to be here. Thank you very much, Steve. Grateful for yet another opportunity to share and dive into the depths of curiosity and wonder with everyone in this likely several part, as you mentioned, series of presentations. I have not been working on this one for very long, but I hope I do at least some justice to some of these great minds who I'm basically trying to elevate. It's really, for me, a momentous and joyous occasion just to be granted another day in this realm of simultaneous beauty and mystery, let alone to share in this particular interdimensional odyssey with you this evening. We will mimic that spiral into the spaceless frequently as this presentation in all segments ventures into the timeless with impunity and disregard. Frequently. So the door to that spaceless, timeless dimension is constructed from the passion of an immense legion of inventive, resourceful, innovative minds across several millennia of preserved human knowledge, at least. That knowledge is recorded in megaliths, expansive earthworks, and the academic and literary works of countless souls, all the way into modern day games such as chess and those of playing cards, thanks to Jordan of alchemical science for that novel observation and I assume rediscovery. So here we go. This will be the planned structure of the parts. This one might be a two-parter. As far as ancient wisdom and mathematical foundations are concerned. For references, both in this intro and the first segment or the first part of this larger presentation, I'll give Steve a hopefully complete list. It's pretty thorough, many of which I will mention verbally and or in the slides. Mostly just for the sake of time, as I've been consolidating a lot of writing for a number of days in preparation for this particular presentation. It's very much a work in progress, of course, but I'm here to subvert expectation of myself included. Much of the artwork you will see was created with DALL-E 3.0. Most of the rest is mine. I don't think I have much of mine in this particular section. On screen, we do have the overall plan. So each segment is listed here. Simply the list of subjects of each chapter of the eventual book, which is looking rather heavy already. So I'm not even halfway through the first rough draft. Every one of these topics obviously can be and is in many cases already the subject of entire conferences or series of them. I don't anticipate I'll be able to keep many of these listed parts whole in under an hour-ish, but at least while doing justice to the luminous wisdom that's exposed our path so brilliantly. So with that said, again, thank you very much, Steve, for giving the space and time. I really respect the amount you've put in over the last 4 decades to give a platform to some of this information and knowledge. Anyway, so 60, 70 minutes is the restraint I'm trying to hold myself to with respect for your time and my energy. We'll see how it goes. Again, big thank you to Steve. I have huge respect for this man and the projects he has helped put together and present to the public on a larger stage than I have myself. So I've been drawing this book, or writing, excuse me, writing and drawing this book centered on total integrated harmonics, also known as universal harmonic resonance, etc. The foundation and thesis of which is essentially based on geometry and the point of conception in any creation, specifically at the dawn of creation in a universe. As all the numbers are inherent at the point of conception / the geometry, a single dot on a page can represent an entire universe from a certain perspective, or a circle, sphere, toroid, perhaps with a simultaneous hyperboloidal dielectric field. Something had to force that point into the 3rd dimension. I define the acronym TIH, Total Integrated Harmonics, as a holistic approach to understanding, integrating ancient wisdom with modern scientific discovery in a synthesis focused on the patterns and frequencies that govern everything, from the quantum to the vast expanse of the cosmos, and exploring these intricate connections through philosophical insight, scientific inquiry, and mystical intuition. Or in a more colorful way, a celebration of profound interconnected wisdom through which we perceive the cosmos as an elaborate system, intricately planned, contained, and constructed, the blueprint preserved in ancient teachings and the vanguard of scientific inquiry. Total integrated harmonics is the song of knowledge, the orchestra that together composes the melody of creation, resonating with the vibrancy of existence itself. We are all reflections and echoes of one another. There is no true differentiation between science and art. Simply said, it's a holistic philosophy that is simultaneously science, math, and art, including music, of course, frequency, vibration, etc. All of these are both sciences and arts. I am eager to engage and speak with many of you this evening and in the future, sharing some good vibrations, whether virtual or connecting physically. This has been and will never cease to be an incredible journey that I'm very happy to still be on. The presentation itself, even this piece of the whole today, is a mighty quest in itself, mirroring the piece of the whole that we all are within these bodies, all fractals of the infinite, stars among trillions. It's my eternal pleasure to be with you all, and I'm humbled and honored to convey some of the most complex and profound ideas in public knowledge for many of us in a digestible form. Given how hardened many of us have become, I intend only to elevate the already infinite wisdom inherent within humanity, paraded across the vast expanse of history, so that it may do honor to our ancestors and those who have begun the chain reaction already beginning to echo through the collective for much of the last few centuries. It's also my goal to help soften that toughness and gently unpeel some of these layers of the onion so much of us tend to guard ourselves with. The stability, yet also the inflexibility. So the vast majority of the time will be spent on our ancestors today, or this evening. While I already feel many of you sighing, that's how most of us have been conditioned to react, myself included. But I will do some teasing and even some correlating to mix it up. That will improve as well when I go back and actually finish this part of the presentation, which will surely be extended to double or triple an hour, in 2 parts probably, to be nice. So the beginning here, we will start in Babylonian civilization, or Mesopotamia more accurately, because the Sumerians are thought to be the providers of the sexagesimal system to ancient Babylon. This was the cradle of civilization, rich in culture and innovation, along the Tigris and Euphrates rivers. They nurtured, I would say, the early seeds of modern mathematics, and also intertwined it with their perception of the universe. So this birthed advancements that have shaped the course of history with the help of the sexagesimal numeral system. That of probably the cultures who became the Sumerians, who likely simply rediscovered it or inherited it themselves. Ancient Babylon, excuse me, mispress, existed for about 1,500 years, starting around 4,000 years ago. Their knowledge systems are intricately linked with the practical needs of their society. Or excuse me, their systems of knowledge intricately linked the practical needs of their society with universal mystery. So their achievements in mathematics are deeply embedded in the culture. Their mindset or worldview was one where numbers are more than just tools. They were the key to unlocking the cosmic mysteries. That's echoed in people like St. Augustine, who said something like, numbers are the language of God. These mathematical achievements were deeply embedded, as I said, and it's a profound philosophy, in part exemplified by the Plimpton 322 tablet and YBC 7289 tablet. So in astronomy, anyway, the night sky, the stars were this wondrous, fabric of cosmic stuff, wondrous cosmic fabric. So when they looked upwards and used this mathematics, this geometry, they charted movements of celestial bodies with such accuracy that it's still quite astounding. And as I said, these were deeply entwined with culture and their spiritual lives, driven almost solely by this advanced understanding of geometry and mathematics. Celestial bodies being charted, predicting lunar eclipses with extreme accuracy. They developed a lunar calendar, which was closely tied to their religious festivals and agricultural cycles, of course. So if you can predict planetary movements, of course, you're integrating these celestial events into your societal framework. And their worldview, where this was extremely important spiritually and culturally. So they also use that for societal governance, the ability to predict lunar eclipses in particular. These were omens And these predictions were crucial to political and religious decisions of the rulers of ancient Babylon. Liz Brack-Bernson and Francesca Rochberg, I hope I'm pronouncing her name right, delved into the evolution of this moon theory and the cultural significance of astronomy in Mesopotamian culture overall, which illustrates how these celestial observations were very important. John P. Britton explored the lunar theory, in particular, the introduction of the uniform zodiac, which reveals the advanced nature of these observations, these astronomical observations, and their enduring influence on how we understand those same celestial movements today. Karen Rea Nemet-Nejat, something like that, and Christopher Woods provided insights into the daily life in ancient Mesopotamia as well, and the role of this celestial phenomena in their religious texts, just to give further insight into how this math and geometry was intertwined with everyday life and spirituality. The Babylonian, I'm going to mispronounce this again, Ephemerides. These refers to the tablets, the stone in particular. So utilizing an improved version of the sexagesimal or base 60 numeral system, which came from probably the Sumerian. Their own culture, as I said, was probably the product of at least two different previous cultures. And anyway, the Babylonians calculated the positions and courses of celestial bodies with this very remarkable precision. And sexagesimal is inherently suitable for astronomical calculations because it's derived largely, or partially at least, from them. But it's also its divisibility. So there's not really a better number, at least under 100 or something, that would, well, even then. Anyway, there's no lesser number. Base 10 has 1, 2, 5, and 10, right? Base 60, you got 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. So just more factors to work with, more integers. The more prime numbers as well. There was something else I was going to say about the primes, but I've forgotten it since. That's okay. So the Ephemerides, I don't know why that's so hard for me to say. These tables tracked paths of planets, the moon across the sky. Later we'll talk about how they charted Jupiter, thousands of years or many centuries, 14 or so centuries before medieval Europe, which is typically credited with being the first. Anyway, I think I got all of that in there. Here's a picture of one of the 4 tablets from Matthew Ossendriver. Sorry, Matthew, if you're listening. He had a paper in 2016 that was published in Science, the journal, called Ancient Babylonian Astronomers Calculated Jupiter's Position from the Area Under a Time Velocity Graph. And essentially, he translated 4 cuneiform tablets that were used to track Jupiter's displacement along the ecliptic by plotting it daily versus the long-term observation of both 60 and 120 days, sexagesimal numbers, by the way. We use these in our time calendars and units of measurement for longitude and latitude. And there's also about 60 heartbeats in a human heart when it's at rest. By the way, we'll get more into that later, but they used the area of this resulting trapezoidal, but as he says, it's not really a trapezoid. It's an abstract trapezoidal. So this is just how they were able to calculate it, which is using things that would be integrated or become integral calculus later, or be part of the foundations of it. And as I said, this predates medieval Europe's calculation of Jupiter's movement by at least 14 centuries, maybe 15, 16, 1700 years. Integral calculus, by the way, just deals with the study of integrals. You can look that up or something if you care to, but it's closely related to differential calculus, and they are the foundation of mathematical analysis. I think this is straight from like Wikipedia, that particular thing, but it's just used to calculate the area under a curve, the length of a curve, the behavior of accumulation functions. This includes integral calculus includes concepts like Riemann sums, fundamental theorem of calculus, integration by parts. Anyway, so if you're interested in learning more, Khan Academy has a good article, at least on this. Anyway, I probably went a little too far with the math there, but he says they date from 350 to 50 BCE or so, which is surprising for me because Alexander died in 323 BCE, and no one really talks about how long it took for it to be abandoned completely, but I suppose 270 years or so isn't that long in perspective. It does seem relatively long given how often they were invaded. Anyway, moving on. So these observations were not just tracking, they really wanted to understand celestial patterns and their implications. So they were among the first to recognize that celestial phenomena were periodic and predictable, which lays the groundwork for modern scientific astronomy. In ancient Sumer, we find the first recorded mathematical system, conceptualized mathematical system that continues to transcend millennia. Around 5,000 years ago, they were adopted and refined by Babylonians, of course, but as I said, its influence endures in modern times, surprisingly subtly in the West. Yet it is, or the West, I should say, but yet it is, it's profoundly embedded in our measurements for time, angles, and geographic coordinates. So we have some of those listed here. 60 minutes in an hour, 60 seconds in a minute. An hour is divided into another category of minute parts. That's why we call them minutes. And then that's further divided into a second group, a second group. I think I got that from Randall Carlson, if I remember correctly. Anyway, so yeah, 5,000 years ago, sexagesimal, base 60, later adopted, refined by Babylonians, but there it is, sexagesimal. So we'll do some sexagesimal fun stuff. It's also used in the Chinese calendar. Plato's Republic mentions the number 12,960,000 and is written as what looks like the number in the parentheses there, if you were to translate it to Roman or Latin numbers. The Almagest, I believe I'm pronouncing that wrong, includes the parts of a degree in the table of chords. We have a spacing issue there. Hellenists are a separate group of people from Plato. Then you have Al-Biruni, John of Saragossa, the Alphonsine or Alphonsine tables, Joost Bergy, or I think that's right, Ursus, his partner, and Henry Briggs, Tamil. If you're wondering about people who also have used base 60 for a wide variety of things, which we'll also get into later, hopefully. So the number 60, highly composite number, as I previously described. It's essentially a masterpiece of the universe's mathematical design. Sounds right. As I mentioned, the rich array of factors, including 2, 3, and 5, prime numbers. So it uniquely is positioned to be exceptionally versatile for fraction representation, simplifying many fractional calculations. You'll see in the sexagesimal, at least the Babylonian sexagesimal numeral chart, they used them for letters too. Like, it wasn't just a number, and this is part of the reason why they had such foundational cultural relationships with the numbers. Anyway, so the practicality, again, manifests in time measurements. Here we have some examples: 360 degrees in a circle, 60 seconds in an hour, etc. And if you were to do doubling of the base numbers out, I think they would end in 59 times 59, which I believe is 3,481. That would be like their times tables, but they didn't do like all of them. They just did the squares for the most part, as far as what their times tables would look like. Many examples throughout history of the sexagesimal system being used for all kinds of stuff across various domains of human activity. So originating from the Sumerians, but them probably having inherited it also. It's been utilized all across history. So astronomy, astrology, navigation, geography, mathematics and calculation, timekeeping, record keeping and administration, mathematical instruments or tools, devices such as astrolabes, sundials, scientific notation, and its persistence essentially reflects its practicality. So it's our inclination to organize our understanding into divisible and manageable units. And obviously we're still using it. So testament to the versatility and enduring applicability almost. So here's some more. Oh, right. Since I mentioned the moon, it moves its own length, or excuse me, it moves its own diameter every hour or so, the length of its own diameter, which is about 2,160 miles, not exactly, anymore at least. And it actually does rotate on its own axis. This is a funny thing. People, since we rarely see more of the moon than the side facing us, there's 8 degrees more at apogee or perigee, I believe. Anyway, its spin exactly matches the Earth, which is extremely suspicious. Clearly designed to me and many others. Anyway, the moon's orbit is elliptical, not circular. So we see slightly more when it is closest to the Earth or at perigee or near perigee. And it slows in its rotation at that point. So the moon cycle takes around 27,322 days to finish an orbit around the Earth. It also takes about 27 days for the moon to rotate one time on its axis. Close to 30, but not quite. This is more just a sexagesimal type of reference. More underscoring its origins, or the sexagesimal system was derived from celestial patterns, the universal rhythms, better way to say that. So it speaks to an early recognition of a kind of mathematical harmony in the cosmos. It enabled ancient cultures to quantify and navigate these rhythms, and it laid the groundwork for modern scientific and mathematical advancements. So as it stands today, it's a testament to our enduring quest to understand and articulate the complex dance of celestial bodies and the passage of time. And it continues to inform the way we structure our lives and comprehend the world around us. As I said, it aligns with cyclical patterns observed in the cosmos, the solar system, the intricate moon-earth-sun relationship, mirrored in our days and seasons, and highlights this deep connection ancient civilizations, our ancestors, had to the natural world in their quest to harmonize with universal rhythms. Sorry if I went off camera there. Forgot my angle. So yeah, harmony with astronomical cycles, alignment with biological and physical rhythms, and adaptation to seasonal and lunar cycles, facilitation of fractional representation. I also found an interesting thing. There's some evidence suggesting that the human mind finds certain rhythms and patterns more cognitively resonant. So the sexagesimal system's ability to make complex astronomical and temporal measurements easier to digest is, or break them, split them into smaller units, is thought to have some psychological advantage of some sort. Not some sort, in terms of computation, but also memory, which makes sense. You know, if you can compute it in your head easier, you're more likely to remember it. Anyway, it's very elegant and very flexible. Astronomers still using it. It's not just used in longitude and latitude, and our astronomy calculations are similar in terms of degrees, minutes, seconds, arc seconds. I think that's all I have on that for now. All right, so Plimpton 322. I don't like how they name these things. It makes it often difficult to remember which one you're trying to find. But this is no simple artifact. This is trigonometry. It's actually the world's only completely accurate trigonometric table, because as opposed to our, we like to list right triangles with a hypotenuse of 1 and approximate the side lengths, whereas the Plimpton 322 tablet lists right triangles with a long side of 1, exact short side beta, and exact diagonal delta. So it's a precision-oriented approach using sexagesimal, and shows how important precision was, several thousand years ago. It's very different, suffice to say, than our traditional trigonometry. So this was a practical need. Needed to measure their lands, needed to construct buildings, needed it for astronomical observations, extremely important for long-term astronomical observation. So this approach within geometry is called Babylonian exact sexagesimal, that was too many quotes, trigonometry. Definitely unique for its time as far as we can tell, and recorded preserved knowledge, available preserved knowledge. So these ratio-based measurements are what's important about this tablet, Plimpton 322. And this also lays groundwork later for later understanding of geometry, trigonometry. And it's also just one part of a very, very, as I alluded to earlier, a very rich mathematical heritage. So Joran Freiberg, I believe is how you pronounce his name, but I'm not totally sure, wrote a paper called Methods and Traditions of Babylonian Mathematics, which unveiled some of these other mathematical practices in ancient Mesopotamia. And basic arithmetic, elaborate geometrical computations, algebraic problem solving. There was a wide breadth of, wide breadth is probably redundant, but of expertise and innovation. And it's this diversity that really underscores the vibrant mathematical culture, not limited to trigonometry and used for all kinds of, their expertise was across a large, advanced intellectual landscape. This definitely challenges traditionally held history of the development of trigonometry, and gives us some very welcome light on ancient mathematical culture in Mesopotamia. It's got a unique structure. As I said, the precision is inherent, and this was, again, part of a broad array used for complex geometry, geo meaning earth, metry meaning measure, earth measure, planet measure, something like that, and algebraic, which comes from an Arabic word, al-jabr, or I don't want to butcher that too much, but which I think means reunion, like of pieces, like back into the whole. So it's the dynamic and innovative approach to mathematical problems, and I'm probably getting a little bogged down in the math parts, so I'm going to speed up a little bit through some of this. But another great example is YBC 7289, and this was a Fowler and Robson paper in 1998 called Square Root Approximations in Old Babylonian Mathematics, YBC 7289 in context. Essentially, it's an accurate sexagesimal approximation to the square root of 2 all the way to 6, or the equivalent of 6 decimal places, which is the greatest amount of accuracy known in the ancient world that I'm aware of. The square root of 2, so 6 decimal places. So here's that chart I was talking about earlier. The tablet itself depicts a square with its 2 diagonals. One side of the square is labeled with the sexagesimal number 30. When I look back for a second, there it was. And here's some examples of how they would write various numbers. You see how they're kind of spaced to denote position. So the first of the 2 diagonals are labeled in sexagesimal. So it essentially, one of them represents the number 305,470 over 216,000. Just a couple orders of amplitude over the approximate, maybe average, maybe base diameter of the moon, which is 2,160 miles. So this is a numerical approximation of the square root of 2, and it's off by less than 1 part in 2 million. The second of the 2 numbers is 547 over 720. 720 is another important number, but anyway, it's the result of multiplying 30 by the given approximation to the square root of 2, and that approximates the length of the diagonal of a square of side length 30. This is yet another ancient example. There's a lot of these of not just in Babylon or Mesopotamia as a whole, but of mathematicians understanding what we call Pythagorean theorem more than a millennia before Pythagoras was even born, which I find hilarious every time I come across another example. We'll skip through some of this. I know I got bogged down in the math a little too much. All right, so on to Babylonian astrology. This is the earliest we know of a very advanced and organized astrological system. And astrology and astronomy were basically the same thing in many ancient cultures. They extended this study of the science of astronomy into cultural and religious practices, as we kind of talked about. This is detailed in Babylonian horoscopes, and that's the title of a book. The creation and interpretation of horoscopes show how they believed in the interconnected nature of celestial events with human activities. So daily life governance was linked intrinsically with astronomy. And again, that's the first known organized system of astrology, and about around 4,000 years ago. And this was used by priests looking to make predictions, weather, war, harvest, fate, as listed there, the influence on humans, and what the will and intention of the supreme beings or being were. What else? I had more about this. Anyway, yeah, so they just believe movements of planets and stars were influential on Earth, and that the gods would communicate this way. Also based on the sexagesimal system. And we'll probably move on. I think a lot of that was straight from Wikipedia, by the way. So not straight from Wikipedia, but same sources. The collective insights from these scholars really I'll use that word too much, but I don't know a better word. Oh, you say profound, and I think the only real synonym is like fundamental, but that doesn't really have the same pop. But the impact of Babylonian mathematics and astronomy is indeed profound. It's their contributions really that lay our foundation for science and math advancement, innovation. They influenced countless civilizations for thousands of years. On to Sumer briefly, even further back in time, southern part of Mesopotamia. They're thought to be the origins of the initial Babylonian sexagesimal system. Also cuneiform script, and we haven't found older evidence is the only reason why I don't just say they are the origin, because a lot of knowledge is destroyed or hidden or otherwise not in the public purview. And that's not just due to human influence in terms of invasions, etc., but also cataclysms, catastrophes of monumental scale. So that's why many cultures built megaliths to preserve knowledge for us, for them, us, same thing. And not just that, but also embedded a lot of these numbers and ideas in things like chess and playing cards. Chess is, if I recall correctly, just a derivation of the game Chaturanga. And our playing cards are simply tarot cards minus 22 symbols, 4 knights, hearts for cups, clubs for scepters, spades for swords, and diamonds for money, or pentacles. And if you check out his video, he has a pretty good one on, Jordan from Alchemical Science has a pretty good video on how chess is encrypted with harmonic numbers. Anyway, and you can read about tarot in Tarot of the Bohemians, I believe, by Pappus. It was written in the late 19th century, if I remember correctly. Right, so sexagesimal came from ancient Sumer, based on the number 60, base 60. And it was simply a rediscovery. I'll just say it. So this is what, more tablets look like. This was around 5,000 years ago that we have the first recorded publicly known sexagesimal system, later integral to Babylon. Again, deeply connected their astronomical observations in daily life, and essentially was revolutionary in mathematics by simplifying very complex calculations, maybe not very, but and understanding celestial movements, important for astronomy, vital to astronomy. Sumerian advancements in math were not confined to abstract numbers. They also applied this in architectural design, agriculture, astronomy, of course. And their astronomy is actually what laid the foundations for the Babylonian system of astronomy, and influenced countless, again, civilizations over 5,000 years. 5 millennia. It's a long time. Or for us it is. Maybe not in terms of the cosmos. The legacy of Sumer is, of course, sexagesimal. we perceive time and space in the same way they did because of sexagesimal numeral system, which we probably would have figured out again eventually if it had been lost, but you know, could have taken a while to be built back up to the form it's in now. Moving on to the Vedas. And here's where I'm just going to start cutting a lot of subjects short because, again, they could be ancient Sanskrit is full of knowledge and a large variety of it. So we have the Badhayana Sulba Sutra, which primarily was about constructing Vedic fire altars. This was around 3,000 years ago, and also contains other. It contains geometric principles like approximations of the square root of 2, and it seemed to inherit, or they already had what is the equivalent of decimal places at the earliest origins we know of. Badhayana being the writer. Kim Plofker wrote Mathematics in India, 500 BC to 1800 CE, and contributed a good amount of this information. So it basically bridges the physical and the spiritual using mathematics. Again, not just a tool, but for construction of fire altars and as a language of expressing the cosmic, the harmonious universe. It's a really helpful to the ancient world's understanding of math and displays advanced algebra and geometry. Again, Pythagorean theorem is evident within the various formulas. And these are altars designed in various geometric shapes, but required the square root of 2 for accurate construction. And this was, again, centuries before Pythagoras was born. I don't think I'll go too deep in here, but they had the square root of 2 down to 5 decimal places, so not quite as accurate as the Babylonians. But it also contains circling the square as opposed to squaring the circle, and more things. Keep going back and forth because I feel like I'm forgetting something, but yeah. A squared plus b squared equals c squared. That's how you calculate, right? Or one way to calculate the hypotenuse of a right angle triangle. So it's quite advanced, essentially. You have the concepts for the square root of 2, not in this picture. This is just how you would draw an accurate square in geometry without using measurement. You just use your compass and your straight edge. And they needed this to double the area of another square. This is reflected in the cities, however you pronounce that. So you have Aryabhata and Brahmagupta in ancient India. Huge contributions in mathematics. Aryabhata is credited with the concept of zero. Brahmagupta recognized for saying 0 is a number minus itself, among many other things. And he formulated rules for negative numbers, which is possibly influenced by similar developments in other ancient civilizations, like Babylon and Greek. Yes. So the Sulba Sutras transcend ritual. It's it's an echo of the same universal language of math, evident in a large variety of ancient civilizations, many of which we're not going to have time to go into this evening, which is a great regret that we probably won't be going very far into the Indus Valley, Americas, or Giza this evening. But that is definitely in the plans. So you see there, not in this picture, but we see in the Sulba Sutras this emphasis on symmetry and proportions, and that this is again yet another example of ancients believing that math is the language of the universe, or geometry, numbers and geometry. Math, all of those are synonymous. And that is, again, a key to the concept of universal harmonic resonance, or as I call it, total integrated harmonics. I'm going a little slow here, sorry. Against this is a relatively new presentation to me, even though the content isn't, and I'm still working out the kinks, but I feel like we're doing well, so I'm going to continue with the explanations of the holistic nature of reality, spirituality, math, physical world. It's all connected, right? Is the idea there behind holistic. And a lot of this knowledge is truly timeless. It's not that it was written a long time ago and it no longer applies, similar to myth or symbology. It matters as much now as it did then and will forever. I skipped a little far ahead there, I think. Right, so let's sum up a little bit about the Sulba Sutras. You have mathematical rigor or precision. You have ritual geometry, but practical beyond that. And then area and volume calculation, and geometric algebra, the square root of 2, circling the square. There's a lot more on that in a paper I have in the references that I wish I had read just now, but we'll move on. It's just another example of math is not just a practical tool. It's a means of understanding, a means of comprehending cosmic construction or order. Timeless, again. So we'll get a little more into Aryabhata and Brahmagupta. It wasn't just geometry. Vedic mathematics has these concepts that are millennia ahead of their time. So we have the revolutionary concept of zero, negative numbers in Vedic text. And has the foundations of modern math and algebra. So Aryabhata lived from about 500 or 475 to 550 CE, an Indian mathematician, just to clarify in case anyone was curious what Vedic or Sanskrit is. And he's credited with a large number of things. We have Aryabhata's theorem, which describes relationship between diagonals and sides of a quadrilateral or a cyclic quadrilateral. Aryabhata's identity relates the product of two sums of squares to the sum of two other squares. Aryabhata's problem, an approximation of pi, was at the time the closest approximate value. And trigonometry, and of course algebra, zero, etc., being part of that in algebra. And some of his work is some of the most important in math. So Shunya, or Shunya, marked a revolution in numerical systems, of course. There's some debate about whether he discovered it, but a mathematician, French mathematician by the last name Ifra, had this quote about how it's proof that he actually discovered it because of his writings and calculations. So also negative numbers. I mentioned Brahmagupta was essential. And essential to understanding the cosmos, right? And the celestial patterns we can observe. So just how total integrated harmonics wants to, analyze and understand the web, the waves and webs of the universe. The Vedic mathematicians were providing us the tools to do so, with numbers. Similarities definitely exist between their math and other ancient cultures, as talked about before, or also referenced by George Ifra, also David Fowler, who we referenced earlier. Ifra's book is The Universal History of Numbers. And Brahmagupta was the one credited with formulating negative number rules, or the foundational stones for algebra, or charted algebra. He lived from about 600 to 660 CE, so not long after, but also made many significant contributions. Brahmagupta's theorem, identity, problem, this list goes on. The Brahmagupta Fibonacci identity, that relates the product of two sums of two squares to the sum of two other squares, and an interpolation formula, as well as a formula for the area of a cyclic quadrilateral, or cyclic quadrilaterals. And these were not just basic calculations, of course. This is high levels of algebra, advanced formulas, used in mathematical theory still to this day, of course, and for problem solving. This is similar to discoveries in Mesopotamia, of course, and in Greece later. Actually, yeah, they're kind of contemporaneous. It's all a reflection of this collective endeavor or quest to comprehend the mystery, or the mysteries of the universe. This global quest or pursuit of mathematical truth, understanding, is timeless, transcends cultures and borders, all of which assists in understanding the foundational elements of harmonics and resonance, which is crucial for understand or hearing the song of the universe. Let's say it that way. We have the Vastu Shastra. This is the geometry of sacred architecture and city planning or urban design. So it takes the various elements of architecture with in rhythm with, or combines the rhythms of nature with our architectural elements. Also from India, in case anyone was curious. And this isn't just construction. This is about balance and harmony between space and the people within it, or the entities within it. This is also an art form, as well as a science, and again, deeply rooted in spiritual and cosmic belief system. It's not just some architectural blueprints. It's a living philosophy. So you have various sophisticated structures and cities in at least described in ancient texts, if we don't have evidence for them physically still, all of which reflect this really deep comprehension of architecture and engineering, and continue obviously to inspire modern architects and engineers. And much of it offers alternative approaches in design, construction, typically in a more sustainable, environmentally friendly fashion. Teaches this as a priority. So we can look at different concepts of materials and sustainability, space, innovation and design, all of which are eco-friendly. So in summary of this section on Vedic texts, even though I've only done about half of what I would like to, the ancient civilizations overall, a multitude across a wide variety around globally, had these same fundamental mathematical concepts. We'll get into more of that with, again, the Americas, the Indus Valley, China, Giza, in another segment, I suppose. Although I would love to have done it this evening. So you have the concept of zero, ideas from calculus. Again, integral concepts in mathematics, physics, engineering, forms the basis of algorithms, computing, numerical analysis. They're foundational and preserved in texts like the Vedas, and the ephemerides, damn it, ephemerides, something like that. So we find the origins of our math and universal application across cultures, across time, across millennia. So now this is the fun part. We get into modern correlations. This is where a lot of my work comes in. That isn't just, rehearsed or reciting other people's work. You not only do you have Aryabhata's calculation of pi, which is really advanced thought of a natural pattern, and his astronomical observations, obviously requiring advanced mathematics and discipline, precision, etc., all of which are parts of magnetism, or the theory of it, at least. Brahmagupta contributed to algebra, obviously the zero definition of zero, negative numbers, and these are all used in electrical engineering and physics. You have quadratic equations, as I mentioned, the Brahmagupta Fibonacci identity, These are used in complex concepts of electromagnetism. Tesla had innovations, of course, in electricity, alternating current primarily, or probably in can't think of the word I'm trying to think of, but his work with alternating current is the foundations of a lot of our current technology. And so inside an alternating current motor, you have the transmission of energy over long distances. And this is grounded in electromagnetic wave and field comprehension. I skipped a little far ahead, accidental mouse. Steinmetz, well, get into Tesla. That's not all I'm going to say about Tesla in the whole presentation, but as far as ancient wisdom and connections are concerned, we'll get into more of that in a moment. But Steinmetz also contributed incredibly in alternating current theory, the law of hysteresis, waves, impulses. I think I missed a word there, but waves, impulses, and other phenomena as an introduction to a lot of electrical engineering theory. He used, but anyway, the law of hysteresis was used in electrical transformers, and that's a practical application of electromagnetism. But it's his mathematics, his symbolic algebra that really helped in advancing that. So the correlation we have is the understanding of cycles and waves and the mathematical foundations, as well as the concept of zero and negative numbers and geometry and electromagnetic fields. And all of these people, all four of the people I'm referring to, Aryabhata, Brahmagupta, Tesla, Steinmetz, they all used an interdisciplinary approach. So they didn't just stick to one field. You have mathematics and geometry to understand natural patterns, as well as their interdisciplinary approach in solving complex problems. And in a different context, you have the groundwork from that mathematics into advanced concepts of scientific thought and electromagnetism, specifically with Tesla and Steinmetz, which they further developed. So there's a continuity or timeline there, which is another concept I tried to talk about, is this universal language of numbers, patterns, harmonics, and especially trying to convey this profound connection between the ancients, our ancestors, their wisdom, and modern science that is the foundation of the majority of our electrically powered technology. So the point is, it's timeless knowledge. It's this universality that's central in the philosophy of honoring ancient wisdom, even within contemporary scientific understanding. And that timeline that connects ancient mathematics to modern electromagnetic theory really shows us brightly this continuous knowledge, this bridge over time, across vast amounts of time, across cultures, through the destruction and birth of civilizations. It's an enduring principle. I believe I'm probably way out of time, but I have much more in this section where I'm trying to bridge to modern science and thinkers. I was going to get into Walter Russell and Nassim Haramein in their unified fields, theories of unified fields that are also similar, and many more. I think I'm about halfway through even this part. Too many uhs. You have Ken Wheeler. He has a more modern interpretation of the Akasha, aka space. This is an ancient Vedic concept. But Wheeler investigates the nature of fields and how they how they align with the Vedic approach is quite remarkable. Helps to understand energy patterns and fields, and bridges the ancient concepts, much of which I'm referring to, with contemporary field theory. There's a work uncovering the missing secrets of magnetism, which goes into more of that, which is obviously focused on magnetism, but he really meant to explain the fundamental nature of the relationship between space and matter and magnetism. The field was an entity, similar to like Kristen Wong's superfluid universe and the quantum field. And he also talks about vortexes. A little Marco Rodin plug will come later. The idea of counter space, as is talked about in electrical theory, up to around when the star in a jar experiments happened in the 30s, which were never practically or commercially applied. Again, until probably more recently. The Akasha, or the space, as the material of the fields and the interplay of energy in that space, and provides yet another holistic view of the universe, essentially. Fritjof Capra and his exploration of the Vedic traditions also provides us some more. I'll just try to skip through a lot of that, but it's the interconnectedness of all things, mathematics as the way to understand reality, harmony, balance, the nature of existence, ethical and moral dimensions, like actual dimensions. Anyway, so another holistic approach, and more we won't get into at the moment. So this is probably, if I'm way over, I'm aware I went kind of slow. This might be a good place to pause, because I still have another 60 or so slides, and that's still only about half of this first segment. What are you thinking on that, Steve?
I think that's good for tonight.
Perfect. Well, again, thank you very much to everyone who joined. I know it was awkward and took a while, but I hope I didn't bore everyone to death. And I'm happy I got through a lot of the history without too much issue, or at least some of it. Again, there's large amounts that we're not covering in this part, but I hope to complete more of what you've already seen, as well as go into a lot of what I had hinted at or briefly gone over in future segments.
Well, I'd like to encourage anyone who has a question to go ahead and send one in. And if you haven't done so, give us a thumbs up on the line below on the YouTube channel there. We really could use the plug. So, and you had a lot of, I don't know if you can see the comments.
I was in the presentation, but I can get into there.
And well, your cousin Michael says hi. Says you
Oh,
crushed.
thank you very much, Mike. He's the ex Blackhawk captain I was telling you about.
Yeah. And so it looks like it got a very favorable thing, and I just hope to see more people click on us. And I want to remind everyone, we do have a conference coming up, and appreciate if you get set up for that. And if you haven't done so already, go over to the YouTube channel and get signed up as a member. $9.99 is a great way of supporting us. We're getting ready to put more videos up there this week, and we a lot of good ones up there already. And then I guess we'll see you next week, and I'll expect to see more of Paul. He has a whole system, a bunch of stuff lined out. And I'd like to thank you again for being a guest and everything.
You're welcome, and thank you very much, Steve. I really appreciate it. It was a lot of fun. This is my favorite thing, is sharing this with others, and hopefully, creating that chain reaction that will help us advance into the eternity.
Okay. And so good night, people, and we're going to call it a night there. So see you all next week.